scenario where the three football players, Ronaldo, Messi and Xavi, are warming up. Ronaldo gets the ball and passes to Xavi. Xavi then passes the ball to Messi and Messi passes the ball back to Xavi, and many such passes are exchanged. Now, it is pretty easy for me to explain this to you diagrammatically. But what if I wanted to explain this to a computer? Computer does not understand diagrams. So, we make a small table with 3 rows and 3 columns. We can have Ronaldo, Messi, Xavi as rows, and to know who the ball was passed to, we have Ronaldo, Messi and Xavi as columns. Let's assume that the players cannot pass the ball to themselves. Alright? Now, based on the passes exchanged, we fill the slots accordingly, and we get here is nothing but a matrix. Matrix is an array of numbers which a computer can decode. It summarizes the entire warm-up section. Consider, for instance, 2, 5, minus 7, 8. This is just a row of numbers, but this can be represented in different ways. We can write it as an array of numbers horizontally like this, or we can write it as an array of numbers vertically like this. The first part, as you can see, has 1 row and 4 columns, and the second part has 4 rows and 1 column. There is another way in which we can write these numbers. The first 2 numbers in the first row and the last 2 numbers in the second row. All of these things which you see here are called matrices. Just an arrangement of rows and columns. But how do we properly define it? Formally, we define matrix as ordered rectangular array of numbers or functions arranged in rows and columns. But there is one important condition we need to keep in mind. That is, each row and column need to have an equal number of elements. See the matrix 2, 5, minus 7, 8. Here, each row has 2 elements. Right? First row 2 elements, second row 2 elements. Similarly, each column has 2 elements. Now, what about this? Is it a matrix? 9, 1, 2, 3, 5. Here, the first row contains only 2 elements, while the second row has only 3 elements. So, it is not a matrix. So, this is the definition. Matrix is a rectangular arrangement of rows and columns in which each row and column should have an equal number of elements. The concept of matrix was introduced by Arthur Kelly in 1858, and the word matrix comes from the Latin word meaning womb. Now, there are a few super basic things we need to know about a matrix. Just 4 things. And the first is elements in the matrix. Second, order of the matrix. Third, number of elements in the matrix. And the last, position of an element in the matrix. Let's zoom out and understand the things in detail. Elements are nothing but the entries of the matrix. It can be numbers, functions or characters. In the matrix A, 3, minus 1, 2, 9, minus 8, 7. These are the elements of matrix A. So, the elements arranged in rows and columns make up a matrix. Let's now discuss order of the matrix. Take the matrix A again. As you can see, it has 3 rows and 2 columns. I repeat, 3 rows and 2 columns. Order of the matrix is 3 by 2. Don't forget, the number of rows will always come before the number of columns. Writing the order 2 by 3 is wrong. In general, a matrix having n rows and n columns will have an order of m by n. So we have learned the order of a matrix, right? Next, we will discuss a closely related concept, that is how to find the number of elements in the matrix. Now, taking matrix A with 3 rows and 2 columns. Now tell me, how many elements does it contain? This matrix has 6 elements. How do we get this? One can easily find the number of elements if one knows the order of a matrix. That is, if the order of a matrix is m by n, the number of elements is given by m into n. Now we come to the position of elements in the matrix. Every element in a matrix has a unique position in the matrix. But how do we define the position of an element? It's very easy. Position is given by row number, comma, column number. So in matrix A, what will be the 1, 1 element? 1, 1 represents element in the first row, first column. So the corresponding 3 is the 1, 1 element. What is 1, 2th element? First row, second column. So the element is here -1. And this goes on, and the last element would be 3, 2th element. It will be 7 in our case. That is third row, second column. After learning order of matrix and position of elements in the matrix, we are in a position to write the general form of a m by n matrix. Matrix A is equal to A11, A12, A13, A1j up to A1n, A21, A22, A23, A2j up to A2n. Likewise, AM1, AM2, AM3, AMJ up to AMN. And remember, on the outside square bracket, we need to mention the order of the matrix, that is m by n. So, we can write it in short as A is equal to Aij m by n, where I represents the rows that is ranging from 1 to m, and the j represents the number of columns, and it ranges from 1 to n. Here both I and j is an element of a natural number, right? Aij represents the element lying in the ith row and jth column. That is, Aij is equal to I, jth element. Next, we will learn how to construct a matrix through an example. Construct a 2 by 3 matrix where A is equal to Aij, whose elements are given by Aij is equal to modulus of I minus 3j. Let's see the solution. In general, a 2 by 3 matrix is given by A equal to square bracket A11, A12, A13 is the first row, A21, A22, A23 constitute the second row. Now, Aij is equal to modulus of I minus 3j, where I takes a value 1 and 2, j takes a value 1, 2 and 3. Find each elements. How can we find? A11 is equal to, substitute the values, modulus of 1 minus 3 into 1, and we get the answer as modulus of minus 2, which is nothing but 2. Similarly, A12 is equal to modulus of 1 minus 3 into 2 and we get it as modulus of minus 5 and that is equal to 5. A13 is equal to modulus of 1 minus 3 into 3 which is equal to modulus of minus 8 is equal to 8. Similarly, we can find A21, A22 and A23 and we calculated and found as 1, 4 and 7. Since it is a modulus function, we know it is always gives a positive value, right? So, the required matrix is A is equal to square bracket 2, 5, 8, 1, 4 and 7, right? Now that we have discussed the all fundamental aspects of matrix, with the knowledge gained, find out where we can use the matrices in our everyday life. Also, in the coming video, we will explore more about matrices, particularly about its types. Now, let's do a quick recap of what we have learned.
Manorama Horizon. Learning made simple.